Hi everyone, welcome to this class. We're going to be talking about ultrasonic sensor. Ultrasonic sensor are simply distance sensor in which you can measure the distance from the object to a particular obstacle. So it measures how far it is from the object and the obstacle, and then send that into centimeter, inches, or whatever measurements calibration you use. So let's jump into the project. But first, the applications of the ultrasonic sensors, it can be used for blind people. It can help them navigate through the streets to know when there's an obstacle and how to dodge an obstacle. This is mostly used in self-driving cars. So self-driving cars now do have ultrasonic sensors or lidar sensors. So these sensors helps in getting distance from the car and other obstacles or other cars. So it will prevent hitting them or causing any collision. So let's start working with ultrasonic sensors. So when you jump into your project, you will on your dashboard, just go click on your circuits, and now you can open create new circuit. So click on create new circuit. Make sure you're signed in first. So after you signed in, you can now click on circuit and open new circuit. So this is our workspace. So let's start programming. So first, let's drag in our components to our workspace. Drag in your Arduino Uno, then you drag in your breadboard small. Okay. All right. So we have our two components. Next, let's go look for um the ultrasonic sensor. Okay, that is an ultrasonic sensor. This is an ultrasonic sensor, but we don't really want to make use of this one. We're looking for a more better model. So let's go to the all. Yeah, so that's all. Category. Okay, so this is ultrasonic sensor we are looking for. So drag out this sensor, then we'll place it on the breadboard. So you discover that there are three pins on the ultrasonic sensor. First one being the power pin, second one the trigger pin, third one the echo pin, and the fourth one is the ground pin. So let's place that on J1, J2, J3, and J4 respectively. Okay, so this is ultrasonic sensor. This is a HCSRO4 ultrasonic sensor. So that's the model name. So here is the power pin. Okay, so first of all, I want to connect all my minus and positive rail to 5-volt and ground respectively. So for my positive rail, I click on the first hole on that roll. The first hole on that roll, I will connect it to the 5V pin. Good, and then I'll change the color of that wire to red. Next, the minus rail, I click on the first hole, the minus rail, and connect that to the GND ports or the GND pin on the Arduino Uno. And that will be black color. Okay, so it's time for me to connect my ultrasonic sensor. The first being the power pin column. Inside that column, click on an empty hole, drag out a wire, and connect it to the okay. I'm going to pass it like this. Then you connect it to your plus rail because you are giving the Arduino 5-volt power. So change the color to red. Sorry. Yeah, because of it signifies power. So next, which is the middle one, is your trick pin. So you connect that trick pin to a so you connect the trick pin to a digital pin on the Arduino. So click on any of the empty holes on that same column connected to the trick. So you must be very, very careful and watchful when you're connecting, not to connect here instead of here. So click on an empty hole, drag out your wire, and then take that wire and connect it to let me use digital pin 5. I'm going to change the color of my wire to blue uh, to simplify data. Then the other one, which is the echo pin, which receives the echo that has been sent. Okay, so we click inside an empty hole on the same column with the echo pin, drag out a wire, and then connect it to pin 6 on the Arduino, and that will be blue color. Blue color. Good. So the last one here is the ground pin, the GND for ground. So we just click on any of the empty holes that's connected to that same column, then connect it to the minus rail on your breadboard, which is already connected to general ground. So that would be um, black since it's ground. Now we will have to add um, the liquid crystal display to the project so we can display whatever sensor data we have from the ultrasonic sensor to display on the liquid crystal. So what we do is that we will go over to our LCD, we'll drag it. I believe you guys now know how to wire up an LCD properly because I'm going to do this quickly so that it won't take too much time. So we need a potentiometer, okay, and also a resistor. Good. So we have to change the resistance to 220 ohms. Okay, so just leave it there. I'm going to need to bring it up. So the first one is ground, goes to the minus side. Second one is VCC, close to the plus rail. Oh, sorry. Let me change the colors for you to understand properly. So power is red, ground is black. And the next one is construct. This goes to the middle of the potentiometer on this wipe. So let's change this to blue. And then for a potentiometer, this is the first terminal. This will go to the plus side of the breadboard to extract 5 volts. That will be red. And the other side, which is the terminal 2, click on an empty hole and then click on the plus side of the minus side of the breadboard for ground, not the plus side, the minus side. So you click on black to change the color. So next one here being the register select. Click there, you drag your wire. So our wiring may start getting more complicated. So you have to look at the schematics or watch the video from the beginning again so you can get all the wiring. So it's not too complicated. Okay, so change the color to gray. Use gray. So this will go to your minus wheel for GND. That'll be black. So the next one, which is the enable, goes to uh, digital pin 11. So it goes to digital pin 11. then um then change the color to gray. So we will now leave 4 spaces in between this and start from DB4. So click inside DB4, that's for digital pin 4, drag out a wire, then connect it to digital pin 10. So DB4 goes to pin 10. Change the color of that wire because these are different sets of wires. Change the color of the wire to orange because they are really relevant for data transfer. So next is DB5. DB5 will go into pin 9. Then change the color of the wire to orange, just as used before. Then next is DB6. That will be on pin digital pin 8. So you need to note all the wirings, okay, and note the number you're placing them. Orange. And then for the last one of our DB, it's DB7. So connect DB7 to digital pin 7. What a coincidence. Yeah, so these are pin 7. So that would be yellow. Sorry, orange. So next for our backlights, which is LED anode, LED cathode, LED anode. This is where our resistor will come in handy. Take the resistor to 180 degrees. Place it on the breadboard. So click on the LED anode, drag a wire, make sure it's on the same line with the first terminal of the resistor to reduce the current that will be entering into the LCD. So that will be red wire. Then the other side of the resistor, click inside an empty hole, then go to the plus side of the breadboard. That will also be red. So this will take power from the Arduino, breaks it down and send a minimal amount of voltage to the LCD. So lastly, I just click on the LED cathode and connect it to the minus side of the breadboard. And that will be black because that's the ground pin. Okay, so that's all for the connections for the LCD and for the ultrasonic sensor. So what we just have to do now is to program it. So I click on the code, delete whatever code I have here. Then I'll go over to text, continue. So I have to remove whatever is here. So make sure your open and closing curly brace is always there. So first at the top, I have to import LCD library. Good. So next, I will have to now create a variable. So I have to put constant to make the variable constant so it doesn't change. The value of those variables doesn't change. So put int, this is the data type. So the name will be given different names. So first of all is RS. RS will be equal to 12 because that is what we connected our RS pin to 12. So we'll be creating different variables on the same line. So all the variables created on that same line will be int and the value will be constant. So RS, the first one, EN, which is enable, is the second one. And enable is connected to pin number 11. So put a comma to separate it. Then the next one will be for our DB4. So let's just say D4. So writing DB4. So D4 equal to pin number 10. Put a comma. Then D5. D5 is equal to pin number 9, comma. D6 is equal to pin number 8, comma, D7, which is the last one, is equal to pin number 7, pin number 7. So the semicolon to close the entire statement. So we just created a one-liner variables. We said constant and int, and then we just started typing the name of the variable, value, name of variable, value, and we separated them by commas. That still works if you want to create a long line of variables which are all the same. So we can still do the same method here. So now we create an instance from the parent L liquid crystal display library. Liquid. So you have to spell this correctly with the camel case. So the exact way it was spelled on the library, that's the same way we spell it here. So then we create a child instance with the name LCD. Then open brackets, close the brackets, and close the statement semicolon. Then you type all the pins from RS down to D7. So you see RS, you just be calling their names here, so it will know the value is already stored inside the variable name. So RS en, comma, D4, comma, D5, comma, D6, comma, D7, which is the last one. Okay, so now we will create an int for both trig pin and echo pin. So we say int trig pin equal to pin number 5. So pin number 5, semicolon. So int again, echo, okay, echo pin equal to pin number 6 at the semicolon. Now go inside the void setup. So inside the void setup, you will initialize and start up the communication between the LCD and the Arduino. So it's LCD dot begin, open brackets, close brackets, and closing the colon. So LCD dot begin, we'll type in the type of LCD you're using is a 16 by 2 character LCD. Okay, so now we'll type in pin mode, calling the pin mode function. Okay, so pin mode. So you have to create a pin mode for both the trig pin and the echo pin. So pin mode trig pin is an output pin because it releases sound wave. So trig pin, comma, is an output pin, semicolon, comma. Then pin mode, open, close the brackets, close semicolon. Then you type in echo pin, comma, is an input pin because it takes in the transferred sound from the sensor and then calculate the distance. Okay, so that's all. So now let's move into the void loop. So inside the void loop, we'll have to this is where the key thing happens. We're calling the function digital write, open and close the brackets. So digital write, we say trig pin, we call the trig pin because it has the value of the pin number. Trig pin, comma, so make it low. So we don't want it to come on, it should stay low. We add the delay, it should stay low for 500 milliseconds. So delay should stay low for 500 millisecond at the semicolon. So next we now create a digital write again. So want to turn on the so the reason why we turn it off because we don't know the state it was before. So as immediately it's coming into the loop, we just want to off it first. Let's know that it's turned off. So it won't give us any bad readings. So that's why we're turning the trig pin off and it should stay off for a particular point in time. So when it's coming on again, we'll now get accurate readings. So say digital write, semicolon, and you type in trig pin variable name, then comma, you now put high. So now we want to turn it on because we are now very sure uh, everything, the noise has been flushed out. Okay, so it has been turned on. So you have to stay on for 1 second. So add a delay. So add a delay. Open and close. So put 1000 millisecond. That's 1 second. So now we'll now turn it off. Then we can calculate it. We can now calculate what is measured. Or we write digital write. Open, close the bracket, close the semicolon. Digital write 3 pin low. So we'll turn it off permanently. Okay. Right now let's calculate the let's get in the data from the echo pin. So the trig pin has traveled. So now it's time for echo pin to receive the echo that's been bounced back from the sound wave that traveled. So we'll create a um a variable. So this is a double because it is a decimal. So it will not give us an integer value. Give us let's just use float. Let's say float because it's more larger. So float and we write duration. Duration will be the name of the variable. So equal to pulse in. Pulse in is a built-in function which helps us to get in the data from the trig pin. So we say pulse in and put echo pin. So it will help us get the data from the echo pin. Echo pin. Alright. Close the statement semicolon. Then next, let's go for our distance. So we will say float distance. We'll create a variable for distance. Alright, so we'll put a comma after the echo pin, and then it takes this function takes in two parameters, which is the pin number and the state of the pin. So we want to turn the echo pin high. So like echo pin, it's time for you to receive the data. So this function will make the echo pin receive whatever distance has been traveled and then to get stored inside this float. So it will calculate how long it took to travel. So from that we'll now calculate our distance. So we create another variable to calculate that distance and say float distance. So the only thing your sensor can do is to check the duration. So you now have to do the calculation for the distance for any of the measurements, either in meters, in centimeters, in inches, whatever. So this is where you do your calculations. So I'm going to do calculations for centimeters. So inside this calculation, I'll first of all type my variable duration. So duration, which is this variable here, it gets the duration. That's the time it took to get the distance. So duration, then multiply duration. So duration with asterisk, use asterisk for multiplication. So yeah, asterisk. So duration multiplied by 0.034 then divide this multiplication by 2. Whatever it multiplies, you divide it by 2. So that's the end of our calculation. So LCD, which is the instance dot print, calling the print function from our library, open and close the bracket, and then we will print distance. So typing the well, let's just say print line. Let's use a print line. So to print on a new line, and then close the statement semicolon. So we want to print the the variable distance. So whatever is being stored, whatever calculation is made in distance, we want to print it on the LCD. So that would be LCD dot print again. So it's LCD dot print to display uh the SI unit. So semicolon, so dot print. Now use double quotation to, because it's a string, it's not a variable. So then use cm as centimeter. So that's all for the code. Let's upload our code into the Arduino board. Okay, so it's successfully uploaded. Now let us increase the construct. Okay, so if you can see here, our LCD is displaying the data from the ultrasonic sensor. It's showing it's currently at 106.80 centimeter. So it's displaying a crazy way. Let's try and adjust it properly. So I'm going to add a delay. So put a delay here. Delay of 500 milliseconds. 500. So try it again. Alright, so you see it's displaying. It's supposed to be printing on the new one. Okay, so it just keeps printing and printing and printing and printing. Alright, so we can now, this is, we're using a simulation, so we have to check the distance. Okay, let's try one more thing here. So the reason why it's showing like that is because we not organize our cursor. There are so many things you can do on the LCD library, like so many. So let's just try out one of them here. Let me use a bonus to try one of them. So let's say LCD dot set cursor. So this sets the cursor at a particular point. Set cursor, open close the bracket and semicolon. So we set the cursor at 0, 0. So it set the cursor at the top angle, just as we did before. We set the cursor at the top left angle. So the first roll, but at the right side, at the left side, sorry. So let's try and upload it one more time. So I'm not code. So yeah, we have this neat work here. So we just keep changing. That's what we want. Okay. So the more we reduce it, you see how it changes over time. Okay, so we can increase. Yeah, it's changing. Turn it this way, changes. So that is how to work with ultrasonic sensor, and you can display your data on the LCD screen. So that's all for this course. See you in our next course, which will be on working with kids. So you have to be physically using kids on the next course. So stay tuned for our next course. Bye bye.